Okay, so we've already talked about how to recognize significant figures and even a little bit of rounding a number to have the correct number of significant figures. Today, we're going to move on to part 3 in your guided notes. So if you turn to part 3, it should read, doing math with sig figs, rounding answer to proper significant figures. We're going to talk about, okay, so when we do multiplication and division, or maybe some addition, how do we know where to round the answer that we get or that the calculator gives us? So I'm going to go through two different rules. The first one is the one that we're going to use more commonly, and that is going to be the rule for multiplication and division. So go ahead and pause and write down that write down what it says there. Okay, so our rule for multiplication and division is that the answer, the one that the calculator gives us, needs to be rounded to the same number of significant figures as the measured value with the fewest. And all that means is when we put two numbers in the calculator, like let's say in the example that's already in your notes, 20.5 is being multiplied by 18. What we want to do is look at those two numbers, so like 20.5, and think, okay, how many significant figures does that number have? That's my first, measured value that I'm plugging in the calculator. So hopefully you said that 20.5 would have 3 significant figures, right? Because it has a captive 0 as well as the 2 non-zeros. And then the other number, 18, has just 2 significant figures. So even though the calculator is going to give us the number 369 as our answer, we don't want to record that as our final answer. So according to our rule, the answer needs to be rounded to have the same number of significant figures as the measured value fewest. So between 3 sig figs in my first number and 2 sig figs in my second number, of course 2 would be less. So I need to round 369 so that it only has 2 significant figures, just like the number 18. So that would be 370, right? Because the 9 causes the 6 to round up, but we still keep a 0 in the ones place as a placeholder, okay? Let's try another one. So this would be division. Anytime we see that fraction, we know we need to divide. So 0.8 grams divided by 3.05 grams. If we do that division, we get a very long answer. I'm sorry, we weren't dividing by grams, we're dividing by liters. We get a very long answer, 0.262295, and then we would just have grams over liters as our unit. But let's focus on the digits in our answer. This is a lot of sig figs, right? This is 1, 2, 3, 4, 5, 6 sig figs, way too many. Okay, so how many sig figs are in the top number that we divided? Right, so hopefully you just said 1 because the 0 is just a placeholder. This 8 is the only sig fig. So we have 1. The bottom number that we're dividing by has 3, the 3, the captive 0, and the 5. But between 1 and 3, of course, 1 would be less, so our answer needs to be rounded to only 1 significant figure. So then what we do is we look at our answer, and starting at the left, we're going to stop when we get to 1 sig fig. So as moving from left to right, the 2 in the 10th place that's the only sig fig I want. However, there's a 6 next door, so that 2 is going to round up. So my answer with just 1 sig fig is 0.3 grams per liter instead of writing down all the numbers that the calculator gave me. And again, multiplication and division follow this same rule, okay? Most of the math we're going to be doing in chemistry will be multiplying and dividing. So this is the main rule you need to get kind of good at, and we'll practice it plenty. But there is another rule, and that is addition and subtraction are treated differently. So go ahead and write out this rule. Go ahead and pause and write. Okay, so this says the answer should be rounded to be as precise as the least precise measured value. So here's what we mean. When I go ahead and subtract 2,490, which is not a very precise number, and I subtract from that 26.7, which is a more precise number, I get this number exactly, okay? Whether you did it on paper or in your head or on a calculator, we get 2,463.3. So the problem, though, is I am limited by whichever number is less precise. And by less precise, I don't mean how many sig figs it has. That rule was only important for the multiplication and division. When we're doing subtraction or addition, it's not about how many sig figs we have. It's about how precise our numbers are. And the way we can tell that is look for your last sig fig. So go from left to right across the number, right? 2 is a sig fig, 4 is a sig fig, 9 is a sig fig, but this trailing 0 is not because there's no decimal. So the 9 in the tens place is our last sig fig. Okay, so therefore, the precision of this first number is that it goes to the nearest 10. So not super precise. Whereas 26.7 has its last sig fig in the tenths place. So tenths is much more precise than tens. So if we look at our answer, we can only be as precise as the less precise of those two values. So tens place is less precise than tenths place. So I had to round my answer to the nearest 10. Okay, so 2,463.3 to the nearest 10 would be 2,460. So again, because there was a 3 next door to the 6 does not round up. I do keep the 0 in the ones place as a placeholder, but it's not a sig fig because there's no decimal. All right, let's try this one. This one's addition. So go ahead and write that down, and if we go ahead and get the raw answer for this, it's going to be 1.918. So go ahead and think about this. Again, we're not counting up sig figs. Remember, we're looking at how precise each number is. So where is the last sig fig in the number 1.50? Okay, so hopefully you said that it is in the hundredths place because that is a trailing 0 with a decimal. So hundredth, what about 0.418? Okay, this one goes to the nearest thousandth. So which is less precise, hundredth or thousandth? Right? So the hundredth is less precise. So we need to round this number to the nearest hundredth. So what is 1.918 to the nearest hundredth? So hopefully you said 1.92 because the 1 that's in the hundredths place has an 8 next door. All right, so we're going to move on later in class and talk about how, we'll get more practice with this. We'll talk about how to use it in our labs, and we'll take it from there.